Okay, Unit 1, Day 4, absolute value and literal equations. Beginning with absolute value. Absolute value is the distance a number is from 0. Okay, so -2, let's go ahead and draw a number line here. If I have -2, let's go ahead and draw that on the number line. Okay, the distance that -2 is from 0, we can count 1, 2. So the absolute value of -2 is +2. Okay, that's asking what's the difference, or sorry, what's the distance -2 is from 0? Well, it's 2. And the absolute value of +2, here's +2 on the number line. How far is that from 0? 1, 2. So basically we're finding whatever numbers on the inside of the absolute value bars, whatever one number is in there, it's just going to be the positive outcome of it. So if I have absolute value of x and nothing else is over here, it's set equal to a negative number. So for example, if I said absolute value of x equals -3, there's no number in here that I could put and say the absolute value of that number will be -3. Now I could say the absolute value of x equals 7. Well, absolute value of what number is 7? I have two options. Absolute value of 7 is 7. So x could be 7, or x could also be -7 because the absolute value of -7 is basically, this is saying what number is 7 spaces from 0? Well, 7 and -7. Okay, so let's go ahead and just use order of operations to simplify. The first one says, wait, if x equals 5 and y equals -3, we're going to be substituting in. So I have 2 times y, which is -3, plus x, which is 5, close absolute value, -4. These tall bars, those are absolute value bars. Order of operations tells me to multiply of 2 times 3, which is -6. Drop down our +5. Okay, I need to finish everything in the absolute value first. So -6 plus 5 is -1. So I have absolute value of -1. Drop down the -4. Now I have one number in the absolute value bars. I can go ahead and solve that. Absolute value of -1 is a +1. Drop down our -4. Now I have 1 minus 4, which is -3. It's okay to have a negative number as long as we didn't take it directly out of the absolute value bars. Part B. Again, instead of x, we're plugging in 5 minus our y. Our y is -3. So I have 6 mushed right up against the absolute value bars. That's denoting multiplication. And then 5 minus -3. Minusing a negative, we can cross the sign to addition. So I have 6 absolute value bar. 5 plus 3 is 8. Now 6 times the absolute 8. The absolute value of 8 is 8, so it's 6 times 8. 6 times 8 is 48. Final answer. Now that we have our basic order of operations down, let's look at it in an equation. It says, when solving an absolute value equation, set up two equations, the left side equal to a positive number, and on the right, make it equal to the negative. So we're going to set up two equations. So we have this absolute value equation, all this equal to 7. So I'm going to set up two equations. The first of which is going to be my 2n minus 3 equals 7. Whatever's in here is going to come out to 7. Okay? Or whatever's in here could be, this could be -7 in order to make this true. So I'm going to set this equal to 2n minus 3 equals negative 7. And I will get two answers. On the first one, add 3 to both sides. On the left, the 3's cancel, so 2n equals 7 plus 3 is 10. Divide by my coefficient on both sides, so n equals 5. That's one of my answers. Second equation, same first step, add 3 to both sides. On the left, the 3's cancel, so 2n equals negative 7 plus 3 is negative 4. Divide both sides by 2. N equals negative 2. So I have two answers. That means if I plug 5 in for n, this comes out true. So 5 times 2 is 10. 10 minus 3 is 7. Absolute value of 7 is 7. If I plug in negative 2, it's also true. 2 times negative 2, that's negative 4. Negative 4 minus 7, or minus 3, is negative 7. Absolute value of negative 7 also is 7, so it works. Let's try the second one. I'm kind of going to separate my work here. First equation, we have 5 minus 3x equals 7. I didn't change anything. All I did was get rid of the absolute value bars. Second equation, I have 5 minus 3x equals, this time the negative version, negative 7. First equation, here's my x term. I want to get rid of the number that's with it. So get rid of this 5, bring it over to the other side. So minus 5. These 5's cancel, so I have negative 3x equals 7 minus 5 is 2. Divide both sides by negative 3. So x equals 2 over 3. And it's negative, so let's bring just our negative sign to the top. That is one of our solutions. Same first step down here. Subtract 5 on both sides. On the left, the 5's cancel. Negative 3x drops down. Negative 7 minus 5 will be negative 12. Divide both sides by negative 3. So x equals 4. You'll have one question like this on that homework. Flip to the next page. We're going to start talking about literal equations. Literal equations is an equation with 2 or more variables. With 2 or more variables, so 2 or more letters, so an x and a y, an a and a b. To solve a literal equation for one variable, use inverse operations. Let's start with some more simple ones and then we'll kind of tear up. So these are one-steppers. So we're going to do a algebraic one and then go to a literal one. So those of you that like to draw the wall, there it is. I'm trying to get x alone, so I'm going to subtract 7 because 7 is positive. On the left, the 7's go away, so x equals negative 12 minus 7 is negative 19. Now let's look what it looks like down here. Solve for a. Well, a is in the same spot x was. I need to get the b to the other side. I'm moving the whole term. It's a plus b, so I will subtract b. On the left-hand side, a drops down. B minus b cancel. Now I have c minus b. Well, those are not like terms, so I just plop them down next to each other. C minus b. And that's my final answer. Next one. Y minus 5 equals 20. I've got to get y alone, so I'm going to add 5 to both sides. That's the inverse of subtracting it. These 5's cancel. I have y equals 20 plus 5 is 25. Same type here. Solve for. I have to get this e to the other side. Right now we have minus e, so let's go ahead and add e. On the left side, these e's cancel. So I have d equals f plus e. Those are different letters. They're not like terms. So I make it f plus e. 3. I have negative 6 times x equals 30. Negative 6 and x are mushed together. That's showing multiplication. I undo that by dividing by negative 6. So x equals 30 divided by negative 6 is negative 5. These 6's cancel each other out. Next one, solve for r. Well, here's our r. 2 pi and r are all mushed together. That means they're all being multiplied. So if I want to undo multiplication, I can divide. So I can divide this side by 2 and pi. That way they cancel each other out. What I do to one side, I have to do to the other. Divide by 2 and pi. On the right side, I have r that drops down. On the left side, c, 2, and pi, none of those are like terms. So I leave it as c over 2 pi. Last one-stepper. Review. I have m over 4 equals negative 8. How do I get rid of this fraction? Well, the fraction is nothing more than division. So undo division with multiplication. Multiply both sides by 4. On the left side, 4 over 4 cancel. I'm left with m equals. On the right, negative 8 divided by 4 is negative 32. Similarly here, solve for v. V is in the denominator. We need to get rid of the fraction. Multiplying both sides by v. On the right side, those v's cancel. So I'm just left with my m. On the left side, I have v times d. No? Okay, that's vd. Recalling, it said solve for v. I don't have v all alone yet. I had to get rid of the function. So now I do kind of what we did. V are being together, that's multiplication. I can now divide by d. On the left, the d's cancel, so I have v equals m over d. Finally have v alone. That's my final answer. That was 2 steps. Let's go on to the next section. Literal equations, 2-steppers. Let's do review. 2-step equation, trying to get x alone. We got to get rid of the piece that's not attached to it, so 9. We're moving the whole term. It's a plus 9, so I will subtract 9 on both sides. 23 minus 9 is 14 equals 2x drops down. These 9's cancel. Still don't have x all alone. 2 and x are mushed together. That's multiplication. I undo that with division. 14 divided by 2 is 7 equals 2 over 2 cancel. And we're left with x. Final answer. Right underneath it. Solve for w. W's on the same side. Okay, so we want to get this alone. Well, we have to move the piece that's not attached first. So 2, that's an L. If you want to use uppercase L so you don't accidentally make it look like a 1, you can do that. So I need to move 2L, the whole term, to the left. It's positive, so I will undo that with subtraction. So minus 2L. P and an L term, those are not like terms. So I just set them next to each other. P minus 2L. Order matters here, okay, equals, these L's cancel, drop down 2W. Still don't have W all alone yet, so I can divide both sides by 2. So I have on the right side W, these two equals P minus 2L over 2. I would accept that as your final answer. Okay? Or you can go one step further. We're dividing by 2, we're dividing all by 2. So you could say I'm dividing the P by 2 and I'm dividing the minus 2L by 2, which would lead you to be able to simplify one more step. P over 2 cannot simplify. Minus 2 over 2, those reduce to 1, so it would be minus L equals W. I'm okay with either method right now, but you should notice that these two are the same thing. You can just reduce one more step. Part 2. Okay, reviewing here. I can multiply everything by what's on the bottom first. Really, this 2 and the y are both on the top, so it looks like 4 equals 2y over 3. I can multiply both sides by 3. 3 times 4 is 12. I just gave the answer. 12 equals. These 3's cancel, so now I have 2y at the top. Divide both sides by 2. So y equals 12 divided by 2 is 6. Okay, literal equation, solve for b. Here's b. Well, I have 1/2 times b times h. So that's everything is being multiplied by 1/2. So the b and the h are in the numerator. So I have b, h on the top, and 2 on the bottom. This 1 could go in front of there. We just don't technically need it. So you can kind of drop that. Now to get b alone, I have to get it out of this fraction. So I'm going to multiply both sides by 2. Two times a is 2a. On the right side, these 2's cancel, so I'm left with bh. Still trying to get b alone. B and h are mushed together. That's multiplication. I undo that by dividing. We want to keep b, so we're going to divide by h on both sides. 2a over h, none of those are like terms. None cancel, so I just leave it as 2a over h. The is capitalized. This is an area formula. Keep it capitalized. On the right, h's simplify out, and I'm left with b. That's my answer. Number 3. First step, I'm trying to get to x, so I have to get rid of the fraction. I multiply everything by the denominator. When I multiply the left side by the denominator, 2 over 2 over 2, so I have that fraction gone. 7 minus 3 equals, I have to multiply on the side as well. So 9 times 2, 18. Add 3 to both sides. Hopefully now you're seeing why it was so important that we really get those 2 and 3 step equations down. On the left, the 3's go away. So I have 7x equals 18 plus 3 is 21. One more step to get x alone. 7 and x are being multiplied, so I undo that with division. X equals 21 divided by 7 is 3. Number 3, I'm trying to get w alone. In order to get to that, I have to get rid of the fraction. The fraction is nothing more than division, so I'm going to undo that by multiplying both sides by m. When I do that on the right side, these m's cancel, so I'm left with w minus 10e. On the right side, s times m, okay, I just make sm or ms. Either way is fine. You could leave it as ms. Okay, nothing, their powers don't change. It does not become ms squared. It just stays ms or sm. Okay, still trying to get w alone, so I get rid of this piece that's not attached to it. Minus 10e, I'm moving the entire term. So because it's minus, I will add 10e to both sides. Sm, I could write Sm or Ms because this is multiplication, so it can have reversed. So Sm and this e term are not like terms, so I leave it as Sm plus 10e equals, these e's cancel, w drops down. Final answer. So you could also have Ms plus 10e equal u. That's fine as well. We've got 5 more examples, and we're going to get into some that look more like putting it in slope-intercept form, and then some that are even more like the ones on that you're going to be tested on. So we have solve for r. Here's r. It's in the middle of p and t. This is an I. Okay, it's in the middle of p and t. P, r, and t are all mushed together. They're all being multiplied. In order to get to r, I can divide it by everything that's not r. So divide by p and t. What I do to one side, I have to do to the other. So I, p, and t, none of those are like terms, so it stays I over p, t equals. These p's cancel. These t's cancel. All I'm left with is r. And I have r alone. That was my goal. Number 2, it says solve for y. Basically, we are writing this in slope-intercept form. This was on one of our pre-tests. We will be doing this so much in Unit 2 that we have to get really good at it. Okay, remember slope-intercept form is y equals mx plus b. So we want the y alone. All right, so here's my y term. I want to get rid of this x term, and I want to put it on the other side. So I'm going to add 9x. I am adding because here it's negative. So they cancel out here. All I have is 3y equals 18 and an x term. Those are not like terms. I cannot combine them. Okay, one's a constant, one has a variable. So I just must put them next to each other. 18 plus 9x. Now I'm going to divide everything by the number that's in front of y, by the coefficient. Every single piece will be divided by 3. Trying to get y alone, so I gotta get rid of the 3. 3 over 3 is 1, so I have 1y equals 18 over 3 is 6. Positive 9 over 3 is 3, and it has an x term. I finally have y alone. That's my final answer. However, if I wanted to write the intercept form truly, we would have the x term first and then the constant. So I'd have y equals, first the x term, so it's positive 3x, so 3x. It's a positive 6, so plus 6. As of right now, I would accept either one of those. When we get to Unit 2, we have to do this, so it's a good habit to start it now. Let's do one more just like that. Solve for y. Write it in slope-intercept form. There's our bar. Okay, here's my y. I want to move the 8x to the other side. It is positive, so I will subtract 8x. On the left side, the x's cancel, so I have negative 4y equals 32 minus 8x. They're not like terms. 32 is a constant. X is a variable term. So we write down 32 minus 8x. You could flip-flop and say negative 8x plus 32 at this point if you wanted to. Now I'm trying to get y alone. I must divide every piece by negative 4. On the left side, The 4's cancel. I just have y equals 32 divided by negative 4. So negative 8. Negative 8 divided by negative 4 is positive 2, and I have an x. Y is all alone. Or I can write it this way. I can flip-flop these. I'm not changing the signs. The 2x stays a positive 2x. The 8 stays negative, so minus 8. Either one is acceptable right now. Number 4, I'm solving for b. Okay, so here is my b term. Trying to get that alone. Draw that wall here. Here's my a term. Let's get that to the other side. It's a minus 13a, so I'm going to add 13a. I'm stacking it under the a term because those are canceling. Over here, here's an a term, so I'm going to stack it plus 13a. There. Drop my b down, equal. CD has nothing to combine with, no like terms, so I drop down CD. Now my terms 7 plus 13. That's a positive 6, so plus 6a. Final answer. B C times D plus 6a. Just rewrote it without the bar. Last one. Okay. This time I'm solving for a. Notice there's a's on both sides. Well, let's go ahead and move. I know a lot of us like to have our variables on the left side, so let's go ahead and move this negative 7a to the left. I'll draw my wall here. It's negative 7a, so I'm going to add 7a, and I'm going to stack it under my like terms. So I have negative 13 plus 7. That's a negative 6a. Drop down our b. We didn't use it. Plus b equals. CD drops down. We didn't use it. Negative 7 plus 7 is 0. I still don't have a alone yet, so I'm going to move the b. So I'm subtracting both sides by b. On the left side, b minus b cancels, so I have negative 6a equals. On the right side, there's nothing to combine, so I just have c, d minus b. We cannot combine them, we just put them left to right like that. A is almost alone. I have negative 6 times a, so I undo that with division. I'm going to divide every piece by negative 6. On the left, negative 6's cancel, so I have a equals CD over that 6. I'm just going to bring the negative to the top. Then I have negative over negative, that becomes positive, b over 6. The negative and negative cancel into a positive, so plus b over 6. I could just divide everything by negative 6, so I would accept this as your final answer. Or if you went from this step and you said, okay, that's c d minus b all divided by negative 6, I would let you keep that as your answer as well, if you just divide the entire thing, because nothing really reduced. If you have questions for this, please be sure to contact me. Otherwise, please find your homework assignment in the module.